Hi class, in this video I'll work a few examples from WebAssign section 7.3 homework. This is adding and subtracting rational expressions. The first problem I want to show you has common denominators. Do you see they both have a denominator of 5z? And so because of that we can combine the numerator to be 16 minus 11 over the common denominator of 5z. 16 minus 11 is 5 over 5z. The last step is to check if you can simplify it, and because these are both monomials and they have a common term of 5, you can simplify this answer to 1 over z. Okay, let's try another example. This example has a common denominator of x squared minus 7x. The numerator is 12x minus 4x, and you see this would be a minus negative 2x squared, which is a positive 2x squared. Now if we combine like terms in the numerator, and I'm going to go ahead and write this in descending order, 2x squared plus 8x over x squared minus 7x. And before leaving that as your final answer, I want you to factor both the numerator and denominator to see if any common factor that needs to be simplified. The numerator is 2x times x plus 4. The denominator would be x times x minus 7. There's only one term to cancel out. Those x terms can go. And that would leave a final answer of 2 times x plus 4 over x minus 7. Now you can leave the numerator as is, 2 times parentheses x plus 4, or you can multiply through by that 2 again to have 2x plus 8 over x minus 7, but WebAssign should take either one of those answers. Okay, so take a look at this one. When we're adding and subtracting, you always need to focus in on the denominators first. We have a denominator of x minus 3 and a denominator of 3 minus x. 3 minus x is almost the same as x minus 3, except the signs are different. And so what we'll do is this fraction, we'll multiply this fraction by a negative 1 over negative 1. And that's okay to multiply by negative 1 over negative 1 because it has a value of 1. And so now the problem is 5 over x minus 3 plus negative 8. When I multiply the denominator 3 minus x times negative 1, the signs will change. So this will be a negative 3 and a positive x. And I'm going to switch them to be in descending order. So this will be x minus 3. Now I have a common denominator of x minus 3, and I have 5 plus negative 8. When I simplify the numerator, it's negative 3 over x minus 3, and that's your final answer. Okay, next we have the fraction 2 over 6u squared minus 11 over 9u. This is the first time we have to find common denominators, and we talked about this in class, or hopefully you've seen a few videos. A common denominator is the same as finding a least common multiple. In just a few minutes I'll show you an example of how we can find the LCM by finding the prime factors. But for now, we could look at this example and work it out in our head. Do you see a common denominator would be 18u squared because 9 goes into 18 evenly and 6 goes into 18 evenly. And then when you're working with variables, the common denominator will always be the variable with the highest exponent. Okay, so now we need to figure out what factor we need to multiply the numerator. Do you see that we just multiplied by a 3 to get 18u squared? And so that's what we would multiply the numerator. 3 times 2 is 6. The second fraction, the denominator was 9u. We would multiply by a 2u to get the 18u squared. We'll multiply by the same factor to the numerator, which is 22u. When we write that as one fraction, it's 6 minus 22u over 18u squared. Before leaving that as your final answer, check to see if you can factor the numerator or denominator. We can pull out a 2 from the numerator. That'd be 2 times 3 minus 11u over 18u squared. The 2 and the 18 can simplify to 1 and 9. And so the final answer, the numerator is 3 minus 11u over 9u squared. Okay, take a look at this example. This is 7 over x plus 4 plus 5 over x minus 1. When you have two binomials in the denominator, the easiest thing to do is just let your common denominator be both of those binomials. So if I rewrite this fraction, the common denominator will be x plus 4 times x minus 1. Now go back up to the original problem. The first fraction was 7 over x plus 4. Because I multiplied the denominator by x minus 1, we need to multiply the numerator by x minus 1. So this will be 7 times x minus 1. We'll do a similar thing to the second fraction. The second fraction was multiplied by x plus 4, so we'll multiply the numerator times x plus 4 to get 5 times x plus 4. Now since the denominator is the same, let me rewrite that as x plus 4 times x minus 1. We can combine like terms across the numerator, and I'm going to go ahead and use the distributive property. This is 7x minus 7 plus 5x plus 20. When you combine those terms together, it's 12x plus 13 over x plus 4 times x minus 1. Now it's okay to leave your denominator in separate factors, or you can multiply them together, but WebAssign should take either answer. Okay, this is the last example I'm going to show you for this video. I just want to spend a few minutes showing you how to find least common multiple of polynomials. You should already have some experience finding the least common multiple, but I want to show you how to use a factor tree to help build the least common multiple. And the least common multiple is the same as finding a common denominator. So one method of finding the least common multiple is to make a factor tree of each term. So 6y squared would be 2 times 3 times y, and 27y would be 3 times 3 times 3 times y. And then from here, we're going to build the LCM. So LCM, and we look at each factor, each number that's represented, and we select which prime factorization use that number the most. So for example, we have the individual numbers 2, 3, and y. So let's look at 2 first. 2 was only used one time in the first prime factorization, so we'll use it one time as we build the LCM. 3, in the first prime factorization, 3 was used one time. The second prime factorization, 3 was used 3 times. So we will use 3 3s as our LCM. And again, we're building our LCM, and we have to always use the factor when it was used the most. The last factor is a y, and you can see that the factor of y was used most in the first prime factorization. It was used twice, so the LCM will be used twice. When we multiply these together, 2 times 3 times 3 times 3 times y is a total of 54y squared. Okay, so let me show you that one more time. And this will just take practice for you to really get good at it. This is 2 times y minus 3. And then the 14 times y minus 3 is 2 times 7 times y minus 3. And so to build this LCM, we'll look back at the factors and figure out which one used the factor the most. They both had a 2. Both of those 2's were only used once in the prime factorization, so the LCM will use the 2 once. The second polynomial used the factor 7 one time, so it will be used one time in the LCM. And then do you see that both of them have the binomial factor of y minus 3? So that will be used once in the LCM. When we multiply these together, it's 14 times y minus 3. Now that was one of the original factors that we were worked with, and that's okay. It just happens that it's also the least common multiple of those 2 polynomials. Okay, so that's all for this homework video. Please let me know if you have any questions. I know some of these problems can get difficult, and I'd love to give you some extra help.